In this lesson, we are going to be writing rational exponents as roots, and then vice versa, which means roots as rational exponents. And then we're going to simplify expressions that have simple rational exponents. A rational exponent is simply an exponent written as a fraction. The fraction as a power in an exponent expression. For example, we would have 8 to the 1/3 power, or y to the 4/3. So from the activity that we took care of in class, we should have found out that x to the 1/n power simply means that that is going to be the nth root of x. Or when we have the p root of y, that can simply be written as y to the 1/p power. When we have a fraction that is to the 1/b power, that's simply going to mean that that is the root and that the fraction is under the radical. And when we have a fraction under the radical, that fraction simply is taken to that power, which is 1/k. So let's go ahead and we are going to rewrite expressions using rational exponents, but we aren't going to simplify. So we have 7, and then this can be written as a rational or fractional exponent, which is going to be to the 1/5 power. In this example, when we write the square root of 30y to the 3rd, we're going to write this to each piece to the 1/2 power. So this is going to be 30 to the 1/2 power, and this is going to be y to the 3/2 power. We could also write it as 30 y to the 3rd in parentheses, and that can be taken to the 1/2 power. In this example, we have 6/13 as a fraction, so we're going to put that in parentheses, and since it is a cube root, that is going to be the 1/3 power. Now we're going to rewrite these rational exponents as roots, and then we're going to simplify them. So when 27 is to the 1/3 power, that's going to mean that that's the cube root of 27. We're going to use our factor tree, 9 times 3 and 3 times 3, and we're going to rewrite our radical in groups of 3. So we have 3 to the 3rd power. The cube root of 3 to the 3rd power is simply going to be 3. 32 to the 1/5 power means that we're now going to take the 5th root of 32. So we're going to make a factor tree for 32. 4 times 8 would be one choice, and then break that down to 2 times 2, and 4 times 2, and 2 times 2. So when we rewrite the radical, we're going to have the 5th root, and we want to look for groups of 5, and it happens to be 2 to the 5th power. So remember that those are opposite operations, so our final answer would be 2. Now we have 16 to the 1/4 power minus 121 to the 1/2 power. So we can rewrite these as roots, so that's going to be the 4th root of 16 minus the square root of 121. If we make a factor tree for 16, we have 4 times 4, and 2 times 2, and 2 times 2. That looks like we have a group of 4 2's, so the 4th root of 2 to the 4th power is going to be 2. The factor tree for 121 is going to be 11 times 11, so that's going to be the square root of 11 squared, which is 11, so 2 minus 11 equals -9. In our next example, we have the cube root of 343 over 64. So we're going to put that into the cube root, and we can do the numerator and the denominator separately. So we're going to do the cube root of each. So we'll make a factor tree for each of those. When we make a factor tree for 343, we're going to have 7 and 49, and then 7 and 7. So we're going to have the cube root of 7 cubed. We're going to do the cube root of 64 next. When we make a factor tree, we have 8 times 8, and then we have 4 times 2 and 2 times 2, and we have 4 times 2 and 2 times 2. So it looks like we have two groups of 2 to the third power. So that means the cube root of 7 cubed is 7, and the cube root of 2 cubed and 2 cubed would be 2 times 2, which is 4. In this lesson, as a review, make sure that you remember that rational exponents are simply the roots. Please remember your rules from earlier sections about simplifying roots. Please remember to do the reflection.